Imagine you're a lawyer.
Just imagine.
You have a career-defining case, and you've just been handed a powerful new tool, a brilliant AI assistant that can research legal precedents in seconds. You ask it to find cases to support your argument, and it delivers a beautifully written brief, complete with citations of past court decisions. You confidently submit it to the judge. Then, the unthinkable happens. The opposing counsel stands up and declares that every single case your AI cited is fake. They never happened. They were completely fabricated. Your reputation is in tatters, and you're facing sanctions from the court. This isn't a hypothetical scenario. It happened, and this phenomenon, where an AI confidently presents complete fiction as undeniable fact, has a name: hallucination. It's the single biggest barrier standing between us and a world of truly trustworthy AI. We see it everywhere: chatbots inventing historical events, giving dangerously wrong medical advice, or creating fake news articles on the fly. It feels like a random, spooky glitch in the machine, but it's not. The truth is, we are actively training AI to lie to us. The reasons why go much deeper than just bad data, and they reveal a fundamental flaw in how we've built the entire world of artificial intelligence. To understand why these brilliant machines have become such convincing liars, we first need to look under the hood at the most common culprits. When an AI hallucinates, the first and most obvious place to point the finger is at its diet, the data it was trained on. At its core, a large language model is a mirror reflecting the digital universe it consumed. And that universe is messy. Think about the internet.
Think about it.
Think about it.
It's a colossal library containing the sum of human knowledge. But it's also filled with conspiracy theories, outdated trivia, biased articles, and straight-up fiction. An AI model, in its initial training, can't tell the difference between a peer-reviewed scientific paper and a rambling blog post from 2008. This is the classic garbage in, garbage out problem.
Garbage. Garbage.
If a model is fed a diet of digital junk food, it's going to learn some unhealthy habits and might confidently tell you that the moon is made of cheese if it saw that claim enough times. Then there's the problem of time. Every model has a knowledge cutoff date. If you ask a model about an event that happened after its training was completed, it's like asking a historian about the future. It has no information.
It's empty.
Faced with this void, the AI has a choice. Admit it doesn't know, or try to construct an answer based on the patterns it's learned. And to an AI, a plausible-sounding answer is often better than no answer at all. This is where it starts to creatively complete information, filling in the blanks with details that seem right, but are entirely invented. But here's the most critical thing to understand about how these models work. They don't know anything. They are not databases of facts. They are engines of probability. When you ask it a question, it isn't searching its memory for the truth. It is performing a breathtakingly complex statistical calculation to predict the next most likely word, and the next, and the next, to form a sentence that looks like a correct answer. Factual accuracy is simply a happy accident of this process, a byproduct of predicting patterns correctly. These are the obvious reasons for hallucinations, but they only scratch the surface. New research reveals a much deeper, more mathematical reason why even a perfectly trained model, fed on perfectly clean data, would still be forced to invent things. And it all comes down to a simple question: is this valid? Researchers at OpenAI and Georgia Tech recently reframed this entire complex issue into a stunningly simple concept they call the "is it valid" problem, or IIV. Forget about generating complex sentences for a moment. Just think about a simple yes or no task. For any given statement, can the model correctly classify it as either valid, meaning true, or an error, meaning false? Their analysis uncovered a stark mathematical relationship. They found that a model's generative error rate, that is, how often it hallucinates, is at least twice its misclassification rate on this simple IIV task. Let that sink in.
Let that sink in.
If a model has even a tiny 5% difficulty in distinguishing a true statement from a false one, it is statistically guaranteed to generate pure fiction at least 10% of the time. This is a groundbreaking insight. It proves that hallucinations aren't some mysterious, high-level emergent behavior. They are a direct, predictable consequence of the same statistical pressures that cause errors in the most basic machine learning tasks. An AI hallucinates for the same fundamental reason it might misidentify a cat in a picture: a degree of inherent uncertainty. It's not a flaw in its personality. It's a feature of its mathematical DNA. The model is constantly weighing probabilities, and when the lines get blurry between what's valid and what's an error, it is statistically pressured to make a mistake. And when a generative AI makes that kind of mistake, it doesn't just output error. It outputs a confident, plausible-sounding lie. This mathematical certainty explains why hallucinations are so persistent, but it also leads to an even more specific and relatable problem. The reason why your AI knows everything about Abraham Lincoln, but can't seem to remember your local mayor's birthday. To understand this, let's talk about something the researchers call the Singleton rate. A singleton is a fact that appears only once in the model's massive training dataset. Think about it. A fact like, "The Earth is round," appears millions of times across the internet. The model sees this pattern reinforced over and over again, carving a deep, reliable neural pathway. Asking the AI if the Earth is round is like asking it to walk down a well-paved highway. But what about a more obscure fact? Like the exact date a specific piece of legislation was passed in a small country, or the title of a PhD dissertation from the 1980s. This information might only appear once in the billions of documents the AI was trained on. It's a singleton. The paper makes a powerful and intuitive statistical claim. If 20% of the facts in a particular category, like the birthdays of notable people, are singletons, then the model is likely to hallucinate the answer for at least 20% of those facts. This perfectly explains a common experience. AI models are brilliant when you ask them about mainstream, highly documented topics. But the moment you venture into more niche territory, their reliability plummets. It's not that the AI is forgetting. It's that the fact was never statistically significant enough to form a strong, reliable pattern in its neural network. Faced with a prompt about a singleton, the model is essentially lost in the woods with a faint, barely remembered trail. Instead of admitting it's lost, it looks at the surrounding landscape, the general patterns of language and information it knows well, and tries to blaze a new trail that looks like it's going in the right direction. This trail leads directly to a hallucinated answer. So we have a mathematical reason why AI is forced to hallucinate, and a data-based reason why it struggles with rare facts. But that still doesn't answer the biggest question. Why are these models so stubbornly overconfident? Why don't they just say, "I don't know"? The answer is the most damning of all. It's because we've designed a system that punishes them for it. The paper argues that the biggest driver of AI hallucination is not a technical problem, but a socio-technical one. It's about the very culture of how we evaluate and measure AI performance. And it all boils down to a powerful analogy: a standardized test. Imagine you're taking a difficult multiple-choice exam. The rules are simple. You get 1 point for a correct answer, and 0 points for a wrong answer or a blank answer. What's your strategy when you come to a question you're unsure about? Do you leave it blank, guaranteeing yourself 0 points? Or do you take an educated guess, giving yourself at least a chance to earn a point? The optimal strategy, of course, is to always guess. Language models, the paper argues, are in a perpetual test-taking mode. The primary way developers and companies measure their models is through massive evaluation benchmarks. Leaderboards that rank AIs based on their accuracy across thousands of questions. The vast majority of these benchmarks use a binary right or wrong scoring system. They don't give partial credit for admitting uncertainty.
There's no partial credit.
A model that frequently responds with, "I don't know," or "I am not confident about this information," will get a lower score than a competing model that takes a guess and gets it right some of the time. In the hyper-competitive race to the top of the leaderboards, honesty is a losing strategy. This creates what the authors call an epidemic of penalizing uncertain responses. We have built a system that actively rewards the very behavior we despise, generating confident-sounding guesses, regardless of their factual basis. The models aren't hallucinating because they are flawed. They are hallucinating because they are doing exactly what we've incentivized them to do. This is a sobering realization. It means that simply cleaning up data or tweaking algorithms won't be enough. But it also points us toward a clear path for a solution. So, how do we get these models to stop lying? For users, it starts with learning how to talk to them. While developers work on a long-term fix, users aren't helpless. You can dramatically reduce the odds of an AI hallucinating by changing the way you interact with it. This is the art of advanced prompt engineering. The first rule is to provide context. Don't ask a vague question like, "Tell me about the project." Instead, provide the model with all the relevant background information in the prompt itself. The more context you give it, the less room it has to invent things. Next, demand accountability. A simple but powerful trick is to ask the AI to cite its sources. This forces the model to ground its response in something verifiable. Be warned, however, that advanced models can sometimes hallucinate sources too, so always double-check them. A more robust technique is to explicitly set constraints. You can literally tell the model, "Answer the following question based only on the provided text." If the answer is not in the text, your response must be, "I don't know." This kind of instruction following is a key skill for modern AIs and can be incredibly effective. But perhaps the most powerful technique is something called Retrieval-Augmented Generation, or RAG. This is a system that businesses are increasingly using. Instead of letting the AI pull answers from its vast, messy training data, RAG connects the model to a small, curated, and trusted knowledge base, like a company's internal documents or a specific set of medical journals. When a user asks a question, the system first retrieves the relevant facts from that trusted source, and then uses the AI to generate a human-friendly answer based only on those facts. It's like giving your AI an open book test where the only book allowed is one you know is 100% accurate. These user-side strategies are essential, but they are ultimately just workarounds. To truly solve the hallucination epidemic, the change has to come from the creators themselves, by fundamentally altering the test the AI is forced to take. Behind the "Why Language Models Hallucinate" paper, propose a radical but necessary solution. We need to reform the entire evaluation system. The core idea is to stop penalizing uncertainty and start rewarding it. Instead of a simple right or wrong metric, benchmarks should be redesigned to award partial credit for honest expressions of doubt. An answer of, "I am not certain," but the information may be related to X, should score higher than a confidently wrong answer. This single change would fundamentally alter the incentives for AI developers. The goal would no longer be to create the best guesser, but to create the most reliable and well-calibrated model, one that truly knows what it knows and knows what it doesn't. The paper suggests an even more direct approach, building explicit confidence targets directly into the evaluation prompts. Imagine a test question that ends with the instruction, "Answer only if you are more than 90% confident." Incorrect answers will receive a negative score. This would force the models to develop and demonstrate a sophisticated internal sense of their own certainty. It would transform the race for pure accuracy into a race for demonstrable trustworthiness. This is the ultimate path forward. It's not about building a bigger model or feeding it more data. It's about instilling a sense of intellectual humility in our machines. It's about teaching them that the most intelligent answer is not always a confident one, but sometimes it's simply, "I don't know." So, we return to that lawyer, standing in a courtroom, humiliated by his AI assistant. The story of AI hallucination isn't just a technical curiosity. It's a story about trust. The confident falsehoods generated by these models aren't just errors. They are breaches of that trust. For years, we've treated hallucinations as a mysterious bug, a ghost in the machine that we needed to exercise with more data and better algorithms. But now we see it for what it is, a predictable, mathematical consequence of a system we designed. We created a generation of brilliant test takers, optimized to guess under pressure. And we are now shocked when they confidently fill in the bubbles with the wrong answers. The journey to trustworthy AI won't be won by simply making our models smarter. It will be won by making them wiser, by changing the very definition of success from a measure of pure accuracy to a measure of reliability. We can finally begin to build AI that doesn't just give us answers, but gives us answers we can truly depend on. Thanks for watching. If you found this breakdown interesting, consider liking the video and subscribing for more deep dives into the technology that's shaping our world.